good afternoon or good morning, depending on where you're at. I apologize for the slight delay in this, but still working out a few bugs on some things. So hopefully everyone has a good experience. And remember, if you have any questions, make sure you put them in the chat window, and we'll address those towards the end of the presentation. So to begin with, I want to go through a couple of things, just kind of some setup information here, just to kind of let you know who we are as a group at ImagineIt. And ImagineIt is a leader in discovery as well as optimization and productivity. All right. We are a division of RAND Worldwide, along with several other companies within the same RAND organization. And we have over 40 offices throughout the U.S. and Canada. The ImagineIt Group specializes in professional services, self-paced learning, as well as online training. We have a partnership with Autodesk, and we have proven performance tools with the Take Aim, Productivity Now, and other award-winning tools. We also have additional partnerships with other organizations, whether we're doing reality capture or other variations of designs and facilities management. Now, we also want to bring up that Autodesk has now launched the industry collections, okay? And those include the architectural, engineering, and construction, the product design, and the media and entertainment collections. We're going to be focusing on part of the product design collection called Fusion 360. And it's actually a tool that comes with Fusion 360. Or Fusion 360 comes with the collection. All right, so if you have questions about any of that, please let us know. We're ready to help transform your business. Now, to begin with, for this, we are going to be using the Fusion 360 and working on sheet metal information here. But I want to give you a little bit of information about myself. I am Robert Savage. I'm a senior education specialist. I train people on the manufacturing softwares. Okay. My experience goes back a long way. I started doing mechanical design in 1984 with CAD software. That was an early version of AutoCAD. All right. I was also a beta tester for Inventor before it was released to the product market. And that was where I started working with a lot more 3D. Before that, I was doing some 3D, but I was focusing primarily on 3D after that point. Now, Fusion, when it originally came out, was actually a subset inside of Inventor. And that was my first experience with Fusion. Since then, I have taught several classes on it. I've even written a class on Fusion, using Fusion to do furniture. I've also taught at Autodesk University on 3 separate occasions for a total of 7 classes, and I think 6 of those were Fusion-based. So I've got a background in Fusion, all right? So I'm a certified instructor as well as a professional certification in Inventor. Now, I want to talk a little bit about Fusion to begin with, just so that anyone who is not familiar with what Fusion is, they get a better feel for it. Fusion is the latest development by Autodesk for the manufacturing 3D modeling product. And it's really centered around having a full and complete work environment and making it accessible by not just businesses, but by individuals also. So there's a couple of things that make it different than other CAD packages, and one of those is the fact that it is technically what's considered to be cloud-based. Now, that doesn't mean that the software exists on the cloud. That means that the files and the licensing exist on the cloud. The advantage to that is I can sit down at any machine that I want, download the software, log in with my profile, and have access to my files. Okay, so that's what they mean by the cloud-based, right? And it's tailored towards top-down design. So therefore, you're working in a single design environment, right? Now, it doesn't mean you can't do bottom-up, because you still can, but it's focused around top-down. It's also one of the main purposes of it is the ability to have a complete work environment. So it's not just modeling, it's also simulation, rendering and animation, manufacturability, and documentation, right? As well as having tools like generative design in it, and even sheet metal as part of the modeling side of it. Now, the benefit for Fusion 360 to the client is, in large part, the price. It's priced very aggressively to get into markets and to be able to be worked not just by industry, but by individuals. I have a seat at home that is my own personal seat that I just use for tinkering with things, okay? Now, let's talk about sheet metal, all right? Sheet metal is an environment within this. And sheet metal benefits you because with sheet metal, you're trying to generate a file that you're eventually going to take and manipulate into a flat and then export in a format where your cutter can actually cut that information for you, as well as other things. So, all right. Now, I want to give you a couple of things that I consider things to remember when you're talking about sheet metal. It's just a few small things. And first of all is have a plan. Doesn't mean you can't go in there and just start building things, but have a focus and understand what you're trying to make, okay? And have a focus as to how you're going to work this. And I'll get more into that as I go through this, and I'll try to bring that back in, all right? And the second point in there is making parts instead of components in there. And actually making parts really kind of is components. What I really mean with that is you have the option within components to make bodies. And one of the drawbacks to making bodies in here, if I've got multiple things that I'm making, is a component or a part can only have one flat pattern. So if you understand that going in, then you understand to make those as separate pieces of information. So, and then the third thing in there is about rules. And when we talk about rules, we're talking about how my data is managed, right, and how my data is controlled, right? Now, the environment or the interface for this is really pretty straightforward. So you have just a standard Fusion interface here, but when I go over to the sheet metal section, it gives me my sheet metal specific information here. So I just kind of want to give you a visual of what part of our objective is here. Now, not all of this is being made in sheet metal, but part of this is being made in sheet metal. I've got a couple of pans here that I'm going to make, all right? And I'll explain what it is here that I'm making as I go through this. So let's kick over to Fusion here. All right, so what I have here is I have my component created that's going to be my sheet metal part here. And so I want to come in and take a look at that. So the next thing I'm going to do, I've got my sheet metal information here. I've got my create tools, my assemble tools, or my modify tools and my assemble tools, as well as my construction information. So in here, if I start a sketch, I already have a plane created down here. And I have that, what I did was offset an origin plane down to the level where I want to create the base of my information. All right. So I've started a sketch there. So I'll switch around to looking at the top of that. And I'm going to start a center point rectangle here off of this. And I want that rectangle to, let me make sure I remember what numbers I have here for that. Pretty sure that's a 35 by 23. So let's go 35 by 23. Okay. Now, I'm drawing this specifically the same size as my opening. I could make that a little bit smaller to give myself room here, but I kind of want to show you what happens when I do this. So now when I finish my sketch, I can then come in and I'm going to use the flange tool. Okay. So what they've done is they've combined several variations of creating information really kind of into one tool. So the flange tool allows me to create a face-based flange, an edge-based flange, or a sketch-based flange. And I'll show you that one here in just a few minutes. So if I come into the flange tool and pick that information, it then brings me over here where I can select which rule I want to use to define that by. All right. I'm going to go right now with my stainless steel 13 gauge. All right. We'll come back and talk about creating and editing rules here in a moment. And then I'm going to look at this just to make sure that it's going the direction that I want for me. So now I'm going to say OK. And now I'm going to come in with that same flange tool, but I'm going to do what's called an edge flange. In other words, I'm going to grab the edge of my information. And I'm just going to grab my arrow here and drag it up. Right? If I look at that, I know what my depth here is. So I know that I want 8 inches, but I want to point out here, these are my 4 edges. I can actually adjust how it's applied to that edge. I'm sticking with full length at the moment, or full edge. I can also do a symmetric offset of those. I can also do two-sided, and I can do 2 different offsets. Okay. Now, I've got my height, and I've got my angle. I stuck with 90 degrees there. And then here I have what's called my height datum, so how it's measuring the height of this. Right now I've got it to the outside, in other words, the bottom of the sheet metal pan up to the top of the flange. That's how it's measuring it. I can also go inside, which would be to the inside of the sheet metal up to the top of the flange. Or if it were at an odd angle, I could do tangent to the bend. Okay? Now, the other thing here is the bend position can be inside of my original sketch, outside, adjacent, or tangent. Right now I'm going inside. And the reason I'm going inside, if I look at this, by doing it this way, originally my edge came all the way out here, but by doing it to the inside, now it fits inside of there. It fits inside of my structural piece, okay? So I'm going to say okay. And I'm going to go ahead and add a couple of more flanges to this. And then I'm going to create something a little bit more complex. But I want to show you a few other things about flanges. All right, so I'm going to add some flanges. And again, I'm going to do an edge flange really around the outside of this. And then I'll actually change that. Now, which line I pick does actually have an effect on it. If I pick the inside line, it's going to it's going to interpret that I want to go inside instead of outside, and I actually want to go outside with this. So as I drag this out, what I want to point out is, notice how these are mitered, okay? And that's this option here, which is the option to automatically miter. If I turn that off, I get flat corners on there, okay? For this one, I actually want flat corners, and I'm going to go 3 inches for this, okay? Because I want a little bit of overhang, and I'll show you why here in a few moments. Again, it does have an effect as to where I'm placing that. Notice how this is coming now down inside of my tubing here. So I'm going to change this to going outside, which means it would lay flat on top of that. The other option is adjacent, meaning it's going to start at that location. And then, of course, we have a tangent if we have an odd angle in there. I'm going to go back to outside just so that we kind of keep it neutral there. Okay, so I've got a couple of more things that I'm going to do with this, all right, to generate information. I'm actually going to come back with a sketch, and I'm going to put a sketch on the in face of that flange. And for that sketch, I'm actually just going to come in here and I'm going to draw in a shape that I want to create. So what I want here is I want basically a J shape here. And I'll go ahead and add a dimension to that with a 1-inch radius in it that drops down 2 inches. All right. So I've got things that I want to be able to store in that. Okay, I've got a hose and I've got a piece of equipment that's round that I want to store in that. So now I'm going to come in and I'm going to use my flange tool again, but what I'm going to select is this as my flange, but I'm also going to tell it that I want to apply it to that edge. All right. Now, I'm going to rotate this around, and I'm going to apply the same thing. I'm going to come over here and add another edge on this side. If I come back and look at this, you can see how it's creating that bend in there and merging that information into this. So I'm going to go ahead and say OK. All right. Now, the next thing that I want to do is I'm going to put a sketch on the top of this, and I'm going to project, use my project geometry to project that outermost edge of that. Okay. Now, the reason I'm going to do that is because my objective here is to come in now and to bend this face off of that edge. I think I actually have to come in and add a line in there over the top of that. So let me go ahead and do that real quick. So the line there represents where that intersection is, but if I put a line down through here, then I'm defining what I want that, where I want that bend to exist. Okay. So if I finish that back off, and then come back over here and say bend again, tell it that I want to bend that. Oh, actually, you know what? I picked the wrong thing there, so let me start that again real quick. What I actually want is I want to make sure that I pick here and then that as my reference to have it bend down. Oh, I want it to go the other direction. All right, so that's the reason I do this. I can say flip bend to send it the other direction. And again, I can come in here and adjust that information so that it makes up with what I'm trying to go around there. All right. I can do the same thing to the other side, but so if I say that I want to sketch on here, and I'm going to do my project geometry, and I'll put my line in where that exists. And come back out of that. And again, go back to my bend. Pick the wrong side as my stationary. You've got to understand what it's asking for here. All right. So as a stationary side, I want that. And then I want that side to bend, flipping downward. And again, I'm going to go back to the center so that it comes in there to fit the way that I want. Okay. So that's kind of the start of my information here. I'm going to add a couple of other pieces to this, but I want to come in and talk a little bit now about my rules. Okay. And so what you have in here is rules, and you have a library of rules that you create throughout this. And that library of rules defines your information. So it controls what you're doing in here and how you're applying information to this. All right? So I want to create a new rule, and then I'm going to change this part to use the new rule here. So what I'm going to do is I have a stainless steel 13 gauge, and what I want to do is I want to create a new one based off of that. And so if I come down here to the stainless steel 13 gauge and I expand it out, this has my basic conditions for this. So if I come over to this, I can say edit this rule so I can make a change to it here, or I can say I want a new rule. And by doing it off of this one, then it's going to do a new rule based off the existing settings of this. But I'm going to change this to a 10 gauge. And with a 10 gauge, my bend on that is 141. And then we have our other settings here. So I want to talk a little bit about some of these additional settings that you can use in here. One of those is your K factor. Right? And so if you're not familiar with K factor, it has to do with the deformation of a material when I bend it. Because metal, when I bend it, contracts on one side and expands on the other. And so therefore it changes the bend allowance or the bend factor on that. And so that's what the K factor does. And so I can adjust the K factor based on mostly my bend and my material. So how much my material is going to stretch and how big my bend is affect that K factor. The 0.44 is just a kind of an industry standard K factor. Okay? So that's what we're going to use there. But I'm going to make some adjustments to things like my bend conditions here. So right now my bend radius is set to thickness. So it's going to go back to this number, and that's what my radius is going to be. All right? But I want to come in here and say, all right, I want my bend radius to be 0.0625. All right? So I don't have to use that thickness as a bend radius. I can come in and define my own bend radius here. I can also define my relief. All right, my relief is when I have two edges that are flanging off of each other. How does it relieve any excess information? Now, we're not seeing that here, but I'll show you here in just a second what I mean by that. Right now, I've got it set to tear. In other words, I don't really want a relief cut in there. I want it just to create it. All right? Now, I also have what's called a relief remnant. In other words, right now, my flanges go all the way to the end. If my flanges don't go all the way to the end, what is the distance from the end before it cuts it off? Okay? And right now, that's set to 2 times the thickness, or 0.282. Right? So if that distance is less than 0.282 to the end, it's just going to go ahead and cut that off. If it's more than that, it's going to put a tab in there. Right? Now, I also want to look at corner conditions, and corner conditions have to do with a 2-corner bend and a 3-quarter bend option. Well, what this means is down here in this corner where I have this information, and I'm going to change that to a tear. I'm going to say save. I'm going to come back here. I've got this created now, so I'm going to close this. But I'm going to do something here real quick in that I'm going to come over here and turn off that frame so that we can just look at the sheet metal piece here. All right. And that corner relief has to do with this information here. So when I've got two pieces coming up next to each other, how does it create a relief in that corner? Right? And there's different variations depending on what you're doing here. Okay. So from there, what I want to do is I now want to come in and add in a couple of more pieces of information just so that you see some additional features being added to this. So I'm going to put a sketch, and I'm going to pick right up here on this top face, and take a look at that. What I'm going to do is I'm going to come in and draw in a rectangle. I kind of want it in the middle of that, so what I'm going to do is I'm going to come back and add some dimensions to this to say I want it a certain distance from that outside edge. So I want that one a certain distance from that edge, and this side a distance from that edge. Same thing here and here. Now, right now, these are solid lines, so it's looking at it as creating a shape in here. But I'm actually going to grab these lines, and I'm going to come over here into my sketch palette, and I'm going to change those to construction, because I'm not generating an object out of those. I'm using those to put points on the corner. And those points are going to allow me to put holes in this so that when I come out of this sketch, I can come in here and I'll go back actually to the solids tool here and tell it that I want to put in holes. All right? And those locations are going to be at those 4 points. All right? So from here, I'm going to set what type of holes I'm putting in this. I'm actually going to go ahead and countersink those. And I'm going to say through all. And let's see the diameter I want on that. Actually, let's say a clearance now. And I'm going to do a clearance anti-metric Actually, no, I'm going to go into unified screw. I'm going to do flathead machine screw at an 82 drill piece. And my size on that's going to be, I'm going to go with a number 8. I can always come back and change it. So that now I have a place to put those screws and screw this down to that part. Okay. So I've got a couple of sketches in here that has visibility still turned on because they're used mainly as reference. I'll go ahead and turn those off. And so now I want to go ahead and look at what's considered to be the flat pattern of this information. Okay. So in here, I have the ability to create this as a folded model and then generate a flat pattern from that. So if I come back here now and I tell it that I want to create the flat pattern, it's going to ask me to pick a stationary face. So this is the face that everything's going to unfold from. So if I pick this base face here, basically, and say OK, then it will generate a flat pattern with the bin lines for what I want to create. Okay. Now I do want to add one more piece of information to this. So now that I have the flat pattern created, I can say finish the flat pattern, and then I'm going to come back in here, add in another sketch on that bottom face, and I'm going to put kind of a drain, or actually an inlet on here, and I'll make it a 5-inch diameter. Finish that. Extrude that through all as a cut. I want it to go that direction. Right. Now, if you'll notice here, that gave me a little triangular symbol over here next to my flat pattern, which means that my flat pattern is now out of date. If I right-click on it, I can tell it to update the flat pattern. That way, the flat pattern now has that information in it. If I want to go back to the flat pattern, I just activate the flat pattern. And now if I want to export this information out, I can just come up here and say export the pattern as a DXF. Okay, so that would allow me to create a DXF that I can send to my machine in order to start generating this cut pattern here. Now, another thing that I can do with the flat pattern is I can actually right-click on it, and I can do a Save Copy As, but I can also create a drawing. So if I right-click on my flat pattern here and tell it I want to create a drawing, I'm going to say from scratch, standard template, but I'm going to go to 34 by 22, say OK. And it will bring in my flat pattern, including allowing me to set the scale, drop that in place, and now I can come in and start adding my dimensioning information to this. But the other thing about this is the bins here. So if you'll notice, I have bin information here, and I have really 3 lines at each bin. The center one, that is a center line, is the bin line. The other 2 are the bin extents. So if I simply come up here to the table and come over here and drop this, notice how it put a number beside these. It put in a bin table, IDing each bin, telling me the direction, the angle, and the radius of those bins. But before I go any further on that, I want to come back here, and I created a different rule for this. And so now I want to go in here and notice this is still set through the stainless steel 13 gauge. If I want to change that, I can say switch rule, come over here, grab my pin, and say OK, and it's going to update my part based on that information. It's also going to update my flat pattern, and if you'll notice, my radius has changed. Because the radius, actually, let's go ahead and update it just to make sure. I'm actually needing to update the flat pattern first. And then we come back over here. Right? And I'm pretty sure I've got to update the information over here too, or at least save it. But the information is tracked across this file, okay? So before we open up for questions, I want to come over here and talk about really kind of my finished variation of this. And so what I want to point out is I came back and created a cover for this also. So if I look at that, there's the pan, there's that, and then this is basically a cover for it. Granted, I haven't put a handle or anything else on it, but this is basically the way my cover would work, and it is its own entity here. I can activate that file, and I can even do a flat pattern of this file because it is a separate file. Now, one of the things I did here was I actually rounded off the corners before I put the flanges on there so that I didn't have sharp edges on there, and that was just a fillet tool. Okay. All right. So in conclusion, the sheet metal environment allows you quick and easy tools in order to generate a sheet metal component that you can then convert to a flat pattern and export out either as a DXF or as a drawing for your information, okay? Now, we're going to go to questions now. If you have any questions, put them in the chat window. I'll be glad to answer any question you have. If you have questions beyond what we've talked about here, here's my information, okay, including my email address and my direct line. I will warn you, if you call that direct line, if I'm teaching the class, I probably won't be able to answer it. So email is probably the best way to get in touch with me, at least initially. But feel free to jot that down. And if you want to contact me with any questions or comments about this, or anything you think I should have done differently with it, please let me know. Other than that, we'll open it up for questions.